we start this class with the wastewater treatment that we have been talking about. Say the primary wastewater treatment, where I have said that we only use some physical means. They contain a number of methods. I have discussed some of that. Say this oxidation pond being one, then say trickling filter being another. Then we have discussed about this so particularly these three that we have discussed, some of these three, these together forms the primary treatment methods, where mostly the physical process is used. We'll come to the secondary treatment, secondary wastewater treatment method. Perhaps most commonly used is this kind of treatment method, where there is a certain objective of wastewater sludge removal or pollutant removal from the wastewater stream. So we'll discuss about one very important thing. There is one very important process what is known as sludge removal. And the process is known as by anaerobic digestion. Most commonly used for civic waste treatment. This has an importance. This is because for very important reason. This is that the participation of anaerobic bacteria. Let me explain you a few things about this aerobic and anaerobic bacteria. You see this, comparing to this is mostly the anaerobic bacteria which carries out this, which is basically carries out about the digestion. That means much of the material would be actually digested by these microbes, by mostly the biobacteria. See, these are anaerobic bacteria. See, what happens is, if you observe this, in any stream of water. Suppose if you just consider a particular stream of water, we consider that there are if you see this fluid like this, okay. If you see that there are a lot of sludges on this at the bottom. Say mostly, if you can think of say any various food items or things like that, where if you keep that for longer time, you will find that the sludges settle. I mean, it's any kind of substances. The sludge is the thickened solid substances which are in a mixture, which are essentially in a mixture. So here you can see here what we observe here in such cases, that here there will be a larger oxygen supply. So here it would be the stage, the process, the state at it can be considered as aerobic state. And here oxygen would be largely depleted, and there would be very little oxygen here because of two things. One is the high concentration of this sludge, high concentration of solid material, and the secondly, essentially there is so much of organic activity here, so much of activity that would be here in this case. So here you would find that the oxygen would be mostly depleted. So it can be considered to be anaerobic state. The situation is the fine line. This fine line is extremely sensitive, where actually anaerobic bacteria and this aerobic bacteria actually differentiate between themselves in two regions. You see, in a natural system there is a tremendous competitiveness in the sense that in the places where anaerobic bacteria generally survive, aerobic bacteria will not be able to survive. In the other case, in the aerobic state where there is aerobic bacteria mostly survive, and anaerobic bacteria may not find it suitable to colonize there. So this particularly, so what you can see, we see an interesting area where now what happens is when this sludge is up to the brim, you can see this sludge is up to the brim, we can observe in many cases like in a civic waste where the sludge is very high, the sludge level is very high, this anaerobic state, the anaerobic column may altogether not exist. So you can see this aerobic state being completely eliminated and the whole state being is under anaerobic state. There are a few interesting things about this. Mostly aerobic bacteria in aerobic zone, the reactions are generally speedier, faster reactions take place. On the other hand, in anaerobic state, the reactions are slow. Reactions are very slow. But one important thing about this anaerobic state of anaerobic bacteria is that one important, as I have said, the reactions are fast in aerobic state, but slow in anaerobic state. Secondly, however, this anaerobic bacteria are more capable in terms of dealing with various pollutants. Anaerobic bacteria are more capable in terms of reducing various pollutants, So here this, if you can just see this, what we observe now is in an anaerobic digester that we have been discussing about. Let me explain you few on this, what is the setup looks like. The setup is somewhat like this. This is a two-stage process. With feedbacks and with the flow coming in, going out like this. So here we see this is what is a typical anaerobic digester. It's a two-phase process. This two-phase process, you can see, observe this. All right. So here there would be a stirrer. See, this is here it is, goes to another tank. I will discuss this process. Here it goes to another tank where Okay, if you just see this, there will be excuse me. So this is, can see this sludge heater. Sludge heater. This is where the raw sludge is coming in. Raw sludge is coming in, and this is digested sludge. Digested sludge. This is supernatant layer. Okay, so this is supernatant out. So you can see this here. We observe this is something like this. Let me go out little fast here. So this here, as you can see, this is the raw sludge is coming in. Okay, this is the raw sludges. You can think of, say, one the typical sludges that we can say the civic waste. Civic waste is one. Then say food processing, waste, and then many other kind of, particularly the pulp waste, say paper pulp, all this, this particularly related to various industries where they can be used. A sludge is essentially, if you can understand, this is high volume of solids, organic solids plus water. This is what is a sludge. This is what would be a sludge, generally a thick sludge that would be. So this sludge is coming in. So the sludge is coming in from here. This is particularly if the sludge heater is there. The role of the sludge heater is to heat the raw sludge. Heating means, as it heats to a certain level, say, particularly in cold countries or in situations where this particularly the sludge is generally low in temperature. Sludge has a low temperature. The reactions take place is at a lower rate. So as a result of that, say that there would be a larger tanks necessary and things like that. So here, what we generally try to do is we try to heat this sludge. As a result of which the microbial activity increases. So here in our country, situation like in our countries, mostly this may not be necessary at times. But here at this, as you can see, in a cold countries particularly, heating the sludge is a requirement just to increase the microbial activity. So what happens now is this particular in the particular treatment system, the first of all mostly all this material, this organic material in the presence of, you can write in the presence of oxygen or without, you see, in heat, with the heat and with the mixing, and some, say, activated sludge, all this organic material would be mostly forming a number of, it also adds to the acidity. Apart from that, this carbon hydrate, this is CH4 that we generally observe here in this case in the methane forming substances, and some unstable products. This will begin to form. And you can see this as the reaction takes place here in the first column. Here in the first column, say the column that we have done here, this one, as this one comes to convert, the organic material slowly begins to convert into water, slowly begin to form into a carbon dioxide, water, CH4, CH2, you can find H2S also forming, say nitrogen. This is a large body of, say, NO3. So here this conversion begins to take place. As a result of this, this is this, from the first tank to the second one, the concentration of water begins to increase. Because much of the water that is produced would be transferred into as a supernatant layer in this, and as a result of these reactions, a scum layer would be developed. Here, the scum layer. You have seen that, particularly, say, if you have observed a part of sweet making or any other processes, you will find the scum coming up on the top, which they continuously remove. Have you seen this in a milk, or in a sweet making process? There will be a scum, white scum coming up on the top. That is what is the scum. This is the scum layer continuously being formed in such cases, and we can find that a certain amount of digested sludge. This digested sludge, this is what is, this is particularly most of this material here is unreacted substances, or say the substances which cannot be readily converted into say carbon dioxide, water, or hydrogen ion like this. The most of this, the digested sludge would be, what would be this digested sludge? The digested sludge would be mostly the cellulose. Cellulose material. You will find tannin in it. You will find tannin and a certain, you can find, other fibrous materials. So this requires a longer time to decompose. I have time and again emphasized that is the carbohydrates, essentially the carbohydrates which are readily oxidized and readily treated. They can be treated very fast, but most of these substances like cellulose, tannin, other fibrous materials would not react. These fibers would completely remain, and they would settle down as a digested sludge. Sometime a part of the digested sludge may be reverted back to the first tank. The reason is activated sludge. The consideration that I said in the last class, why activated sludge is required. So this activated sludge may be recycled back. So this is what is called sludge removal by anaerobic digestion. We can see this complete digestion taking place here, as a result of which the raw sludge, a substantial amount of raw sludge will be removed. A substantial amount of the solid fractions in the sludge would be removed and be converted into liquid fraction, and as a result of that, most of this material would be without much of carbohydrates, and they would be, whatever they would contain, mostly contain most of these higher organic substances like cellulose, tannin, fibrous materials, or any other hydrocarbons that we can think of, which are not volatile, which are generally solid, which may be liquid or solid form, remain in the digested sludge. All right. See, this is one kind of sludge removal that is generally is of great importance. So this comes, why I have discussed this is this process, this kind of processes are becoming very important nowadays. Microbial digestion is a new area of research in wastewater engineering as well as in environmental science. We are more and more dealing with these substances, with these organisms, to create situation by which natural means can be employed for remediation. Natural means can be employed for remediation of most of these substances. So here, the second, the very important other, the chemical unit processes. The next is this is a major heading, chemical unit processes. Chemical unit processes, where we would be generally using some kind of method or treatment for say treating the waste. The process, just let me make some differentiation here. Application, process and application, where we can process, where you can use this. This is say process is chemical precipitation, say removal of phosphorus, then removal of metal hydroxides, and metal hydroxides, phosphorus, metal hydroxide, then sulfides. So removal of phosphorus means removal of phosphates also. Just to say that the phosphates are the sources of phosphates. As you can see, many of these phosphates are coming through the fertilizers. Detergents are the major sources of phosphates nowadays. And the chemical used for this purpose is one of them is alum. So here this is alum is Al2SO4 3 18 H2O, or you can see this Al2SO4 3 14 H2O. This is the combination that we generally observe. Say this chemical precipitation, adsorption. The adsorption is the methods for adsorption is this is also a very important area now. It says a lot of materials are being now used for adsorption. Say this particularly the adsorption are the rock surfaces, broken rock surfaces that we have observed, particularly in the trickling filter. Rock surfaces, say that nowadays a lot of substances are being used, say this for particularly say the adsorption of rock surfaces. Say adsorption of this, particularly what we do is adsorption of say a number of metallic and non-metallic adsorption of number of metallic and non-metallic compounds. The material that are being used are interesting array of materials are now being used. Say one of them is charcoal, that I have said. Charcoal is one very important area of where adsorption are being thought of. Say this activated leaf litter. We have done a number of experimentation on this activated leaf litter. We can observe, particularly this phenolic adsorptions. Phenols can be activated leaf litter. Leaf litter is the leaf that falls off from the tree. This remains as a very good substance. I mean, it's generally mostly those things are burnt, but these substances are rich in cellulose and rich in high surface area, and this makes a very good component. This makes a very good material for adsorption. Particularly, a number of material can be absorbed in the activated leaf litter. Activated sawdust, all these things are being used for adsorption nowadays. So material, so you just try to understand this as a process. You would be mostly the polluted wastewater. You might require to do some pre-processing, like a size, maybe classifying to a size may be important. You run a particular stream of water over these surfaces, and design the process in such a manner that they remain in contact for a long time. As a result of that, most of this material will have a very high surface area, and they will be mostly porous also. So as a result of that, many of the substances will have a natural affinity to remain attracted, with the surfaces, and as a result of that, the concentration of a particular pollutant begins to reduce. Okay, this is the adsorption process. So the material that I have already explained, what are these things do you generally use? One, we also use disinfection. We generally do not particularly try to remove any material. Instead of that, we generally want to exterminate or kill some of the microorganisms. Say this is to reduce the application, to reduce the disease causing to microorganisms, use the disease causing microorganisms. There are some microorganisms I have discussed in the water pollution, the type of pollutants in water. So the disease causing microorganisms, like which are generally related to water hygiene, water sanitation. All this we have discussed earlier in this water treatment, water pollutants. So these are mostly the famous ones that we generally know is that ferric chloride, then it is ferric sulfate, also used as chemical precipitation, also used in Fe2SO4 ferric chloride. This is then you can say that Fe2SO4 3H2O, and another very important and greatly used, is calcium hydroxide. Calcium hydroxide comes for precipitation. So disinfectants that we can generally find these disinfectants being used, particularly the chlorine. There are certain bromides also are being used. Say this bromine chloride, BrCl2, right? Bromine chloride. Then ozone is also used. say UV is also used to disinfect UV, and particularly various kind of substances that generally we use. And another very important part, we should also discuss about this, about this chemical precipitation. Let us, this is one, you write chemical precipitation, chemical precipitation 2. This is almost the same, only thing, just because I didn't write it there, so let me write it here. Is mostly the purpose remains the same. Purpose remains the same. Selective sedimentation of targeted substances, targeted pollutants. Calcium hydroxide, or you can write it as CaOH2O. This is a very popularly used. So these are the chemical unit processes that are generally used for different purposes of this, particularly in dealing with the wastewater and for dealing with this the process of using these chemicals, using mostly these chemicals. Let us further discuss on some of those things. What are the standard reactions that are generally involved in use of alum that we have used, generally used, alum that we have known, Al2SO4 to 18H2O. The reactions generally, when an alum is used in the process, the intervening reactions are very important, of great importance to us. Al2SO4 3 and 18H2O forming with, say, 3 this is forming 3CaSO4 . This aluminum hydroxide is used as a flock. This is a gelatinous substance. Gelatinous is basically a gelatinous flock that would be settles slowly. When this, you can find that much of this is, and also a part of this carbonate is becoming, this carbonate is essentially targeting the carbonate, the bicarbonate being converted into, broken into calcium sulfate and carbon dioxide. So as a result of that, the dissolution of bicarbonate taking place. So alum, actually this is the alum, by which you can see the gelatinous flock, which is a result of a precipitation here, and what we are trying to remove is calcium bicarbonate. So this calcium bicarbonate and this magnesium bicarbonate, this is also you can see this, the same can be for magnesium bicarbonate also, which is greatly. You can see this all related to the hardness of water. So reduction of hardness of water by using alum. Reduction of hardness of water by using alum. The typical process is like this. The typical process is like this. And another very important thing is that about lime. I will discuss about the other general purpose of these processes, but let me just explain you what are the reactions involved. The lime is that when the lime is added, you see this lime is added. This is lime plus is H2CO3 as a forming of this. This is calcium carbonate plus 2H2O forming here. What is Ca? Another reactions that we generally observe is CaOH2 plus Ca. Two CO3 plus 2H2. So here also is a carbonate reduction process. Is a basically particularly mostly this the carbonic acid, hub bound carbonic acid. This is carbonic acid. And this is calcium bicarbonate, as you know, calcium bicarbonate. So as a result of this, this calcium carbonate, begins to precipitate. Calcium carbonate begins to precipitate. So this is the typical methods, typical processes that I use. Sometimes we use lime plus ferrous sulfate. Lime plus ferrous sulfate. This lime plus ferrous sulfate, the usual this is an usual method of bicarbonate removal. So here we can find it Fe CaSO4 plus 7H2O. This is ferrous sulfate. That ferrous sulfate that we have said, the ferrous sulfate is also used as a disinfectant, plus calcium bicarbonate, forming ferrous bicarbonate. This is when this ferrous bicarbonate then further reacts with this ferrous bicarbonate, then further reacts with this is what begins to precipitate. This is what begins to precipitate. This is also lime and ferrous sulfate. When are used together, you can see how it can reduce this, the bicarbonate alkalinity in water, right? So this is just the method of lime precipitation, the method of precipitation that we generally use in cases like this. So this, we will consider that you see here in cases like, say, the requirement of lime and oxygen like this. So these are the standard reactions that generally form in the chemical precipitation process. We would more discuss about the lime precipitation. This is because the lime precipitation is of absolute importance and a major method of secondary treatment. So we would just bring lime precipitation here. As we have already said, that discussion here is lime precipitation that we generally observe in such cases. The lime precipitation remains, the lime precipitation is one of most commonly used method of bicarbonate hydroxide and sulfate removal. Sulfate also we have discussed about, we have seen mostly about the sulfate removal. I will discuss about that. What happens here is, one very important thing is, this is the one important property, that is what is known as amphoteric properties of metal hydroxides and sulfides. This is of great importance. See, please underline this: amphoteric properties of metal hydroxides and sulfides. What happens is that the solubility of the metal hydroxides and sulfates, metal hydroxides and sulfates depend, sulfides, as they are formed. Please see the above reactions. As these hydroxides are formed, the solubility of metal hydroxides and sulfates as they are formed depends on the pH of the solution, or pH of the solution or the mixture. This is what is important. One is this calcium hydroxide, most of these calcium hydroxides, or say magnesium hydroxides, even say then other metallic hydroxides, they, when they are formed, many of them are perfectly soluble in water. It's perfectly soluble in a medium of water, where there is water is the major medium. Now what happens is, they are soluble they are soluble only in a particular pH range. What is observed is the amphoteric property here. What is generally observed is the amphoteric the solubility the solubility is minimum at a very definite range of pH of the solution. What is pH of the solution? I think the pH, acidity or alkalinity of the solution. Okay, the solubility is minimum at a very definite range of pH of the solution. This is so. This range is understandably the range is different for different hydroxides, different hydroxides and sulfides. This property is known as amphoteric, amphoteric, amphoteric property. This property is greatly used. This property is greatly used to selectively precipitate this property is greatly used to selectively precipitate the hydroxides and sulfides. This property is greatly used to selectively precipitate the hydroxides and sulfide. Remember this. So what we see is this is something like this. If you just see the pattern here, if you just observe the pattern here, what we are trying to do is we will try to find a mixing chamber. We will find a mixer here. Okay, so this is where this is the stream, the influent, this influent is where this we are mixing with, say either lime or ferrous sulfate or lime or say ferrous sulfate of lime, ferrous sulfate of lime. All right, now this is when it is going from one place to another, this is going from one place to another. What we try to do is this particular this liquid, we would try to control the pH here. We would try to control the pH here, say at a particular range. Say pH, we are finding pH we are keeping between x1 and x2. pH we are measuring keeping between x1 and x2. So what happens is here we would have this is by how it is would be done by mixing buffer. So we will use the buffer to control pH. So if we are mixing the buffer to control pH, we would find a selective deposition of a particular hydroxide or sulfide. Okay. The next is, so next the stream continues. The stream continues, we carry out the stream, we use the same process, say here we generally maintain, say similarly we maintain a particular, we are particularly maintaining another pH by using the buffer, as we have used in this case. We are using this buffer here, using this buffer we are maintaining the, say, pH between, say, x2 and x3. Okay. Now we can selectively precipitate another particular hydroxide. So this is the use, this is the process, which is of grain. So here this can continue, this process can continue. What we are trying to do precisely is, after the water has been mixed with, lime and ferrous sulfate here in this case. So as soon as that forms, the hydroxides would be formed, different hydroxides would be formed. These different hydroxides will be selectively precipitated. What we would try to do is, we would try to maintain the pH, the range of the pH at which the solubility of a particular metallic hydroxides or sulfate is minimum. If it is minimum, then only it would come out of the body of the water, it would try to settle out, this would begin to precipitate. So, okay. So this is what we are selectively precipitating a particular, say, M1 OH2 OH, right. This one is M1 M2 OH, a particular kind of hydroxides, are being selectively separated. This has a great importance. This can only be achieved by the use of this amphoteric property. The amphoteric property suggests that at a particular range of pH, if we can maintain the pH at that level, the solubility of the metal hydroxides or metal sulfides would be minimum, and this would be different for different metal hydroxide, metal sulfides. Okay, and that is how we would selectively precipitate all these substances. Okay. Lime precipitation is a very greatly used process. Is almost all major chemical treatment methods, much or more than 90% of the chemical treatment methods, wherever and however it is done, lime is used. So lime as a method, this is a very common method, very cheap method, very simple method to work with. But plant performance and other things are certainly a matter of concern, because the scaling begins to reduce the effectivity of this treatment. However, it is quite common method as a method. So okay, we stop here. We'll begin the class again, and we'll see how we can do it again. Look forward to this.